Now we'll see a new topic, stoichiometry, which uses the mole concept also. One of the most important aspects of a chemical equation is when it is written in the balanced form, it gives quantitative relationships between the various reactants and products in terms of moles, in terms of masses, or molecules and volumes. This is called stoichiometry. In Greek, the stoichiometry means it is to measure an element or measure reactant compounds and product compound. The coefficients of the balanced chemical equations are stoichiometric coefficients. For example, a balanced chemical equation along with the quantitative information is given by this equation. See here, calcium carbonate reacts with hydrochloric acid to give calcium chloride, water and carbon dioxide. So these coefficients, these numbers are the stoichiometric coefficients of the reactants and products. What does this reaction convey to us? If you consider these coefficients as molecules, how will you read this equation? One molecule of calcium chloride reacts with two molecules of hydrochloric acid. But is it possible to perform a reaction with only one molecule of calcium chloride and with only two molecules of hydrochloric acid? Because atoms and molecules are very, very small, therefore the reaction will not take place in terms of molecules. It is not possible to perform reaction with only one molecule of calcium carbonate with two molecules of HCl. Therefore, this reaction can be read in terms of moles. That is, I can read this reaction as 1 mole of calcium carbonate reacts with 2 moles of HCl will form 1 mole of calcium chloride and 1 mole of water and 1 mole of carbon dioxide. So I can read this stoichiometric coefficient in terms of moles. 1 mole of calcium carbonate, 2 moles of HCl, like that. Also, we can convert these moles into mass. How will you convert moles into mass? By using the previous formula. Number of moles is equal to given mass by molar mass. So you have to convert into mass, which means the number of moles is equal to m by m. The number of moles multiplied by molecular mass, which gives the mass of the substance, which correspond to the number of moles. Right, which means 1 mole of calcium carbonate, which means 1 into its molecular weight. How much the molecular weight of calcium carbonate is? 100. That is 100 grams of calcium carbonate is 1 mole of calcium carbonate. And 2 moles of calcium carbonate mean 2 moles of HCl means 2 into its molecular weight is 36.5, which is equal to 73 grams of HCl. And how much calcium chloride is formed? 1 mole of calcium chloride is formed. That is, its mass is 1 mole into its molecular weight is 111. That is 111 grams. And 1 mole of water is formed. Its molecular 1 into 16, which is equal to 18, which is equal to 18 grams. And 1 mole of carbon dioxide, which is equal to 44 grams of carbon dioxide. This is 1 into its molecular weight. Molecular weight is 44 grams. So now you can check the law of conservation of mass here. So that is, the total mass of the reactants is equal to total mass of the products. So this kind of quantitative information conveyed by a chemical equation helps in a number of calculations. Let us do one problem. Calculate the amount of water produced by the combustion of 16 grams of methane. So methane on combustion means burning in the presence of oxygen. The hydrocarbon on combustion gives the products carbon dioxide and water. we have to balance it first. So it is not balanced. So let us balance first. So you get like this after balancing. So what does this combustion equation convey to us? 1 mole of methane reacts with or combusts with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. What is the question? Calculate the amount of water produced by the combustion of 16 grams of methane. So here in terms of mole, it is like this: 1 mole, 2 moles of oxygen, 1 mole of carbon dioxide and 2 moles of water. It is converted into grams. 1 mole of methane is nothing but 16 grams of methane. And here 2 moles of oxygen means 2 into its molecular weight. That is 32 is equal to 64 grams. Here 1 mole of carbon dioxide is 1 into 44 equal to 44 grams. 2 moles of water means 2 into its molecular weight 18 is equal to 36 grams. But the question is related only with methane and water, so we don't bother about these two. So calculate the amount of water produced by the combustion of 16 grams of methane. So here 16 grams of methane on combustion gives amount of water is 36 grams. So it is a direct question here. Suppose if the question is calculate the amount of water produced by the combustion of, instead of 16, 64 is given. So how will you do this? The same question, instead of 16 grams of methane, 64 grams of methane is given. So calculate the amount of water produced by the combustion of 64 grams of methane. So we know that according to the balanced equation in terms of mass, 16 grams of methane produces 36 grams of water. Therefore 64 grams methane produces how much? Is equal to 36 by 16 into 64. Right? It is equal to 4 times. 144 grams.